Okay, topic 8, section 1, right triangles and Pythagorean theorem. This is the third time we've interacted with the Pythagorean theorem. The book only has it the second. I gave you a first, right? So you guys were supposed to write this down. What is it?
A plus B squared equals C squared.
A squared plus B squared equals C squared. Could I write it C squared equals A squared plus B squared?
Yes.
Yes. You have to know it. I've told you that from day one. Gotta know it. C is always the what? Okay, C is always the hypotenuse. No. How about I spell it right? OTENUSE. Which is across from what?
Looks like a right triangle.
Right angle? The whole thing is a right triangle. Okay, so C is always across from the 90-degree angle. Does it really matter what A and B are?
No.
No, they're two legs. They're two legs. It doesn't matter which one's A or B. I've heard some teachers say they tell their kids A is always the shortest leg or B is always the shortest leg. But does it really matter? No. C has to be what? The hypotenuse, which is the longest side. Add that if you don't remember, because you're going to need to know that, correct? The longest side. C is always the longest side. It is always the hypotenuse. Okay, we can write A squared plus B squared equals C squared also like if I needed to solve for them, correct? So if I needed to solve just for C, what would I take of both sides? The square root. So it'd be the square root of A squared plus B squared, wouldn't it? And if I needed to solve for a leg, let's say I'm going to solve for A, I would subtract B squared over, wouldn't I? And take the square root. So it'd be C squared minus B squared. And all of these we've done before, right? And B, but it really doesn't really matter, right? You would subtract A, and you would have what? C squared minus A squared. But again, these two are the same, aren't they? Solving for A and B, we do exactly the same thing. Does the hypotenuse have to come first?
Yes.
Yes. Because if you don't, and the hypotenuse is the longest side, you would subtract them and get a negative number. And can we take the square root of a negative number and get a real number? No, we cannot. We are not in the business of getting the square roots of negative numbers, not to algebra 2. Got it? Okay, so the converse means the backwards of this. So it was, if the triangle ABC is a right triangle, then A squared plus B squared equals C squared. So if, flip it around,
C squared plus
C squared equals A squared plus B squared, then it is a what? Right triangle. Now, if this happens, the sides are said or sides are known as Pythagorean triples.
I don't even want pizza. It's like beef burger, You want some pizza? Flavored.
Oh, how about I spell triple right? But I am going to make mine. It's L-E, isn't it?
Wow, it was amazing.
Okay.
like
You need to be back in class before 13 minutes after class starts.
Where's Xander
Sandy's,
at?
yeah, Sandy
Okay, I
is-
know, he's
I
still
am
gone.
taking a dump.
So,
I am-
okay, this is recorded and not the whole world needs to know that.
I forgot about that.
Okay, if this is true, the sides are known as a Pythagorean triple. It's going to ask you, do these make a Pythagorean triple? But if they make a Pythagorean triple, they're a what triangle? Right triangle. They make c squared equals a squared plus b squared true. Okay, so if they ask if they're Pythagorean triple, they're just asking if it's a right triangle. That's all they're asking.
Did you hear it?
Yes, I heard it.
No, you saw it.
And your face is uncovered. Throw it out. Sander?
Yeah?
Next time you are this late, you are absent from class.
Okay.
Okay, so find the missing side of the triangle. I have a right triangle, yes? Okay, so what do I use to find the missing side?
It'd be the A squared plus B squared.
What is that called?
The
Pythagorean theorem. Now, we are going to learn some special right triangles that we don't have to do that on, but you use the Pythagorean theorem. So we're looking for what?
Looking for AB.
AB, which is what part of this triangle?
Let's
No,
see.
the hypotenuse.
It's the hypotenuse that is C, correct?
Yeah.
So we're going to have C equals 12 squared plus 15 squared. This is why your squares and cubes are important. Your graded quiz on Thursday is going to be like 30 points, and you're going to have squares and cubes along with it. Okay, 2 minutes. So, 12 squared is
144.
144 plus 225. So I have the square root of 369. So we are not going to have decimals. We need to have reduced. So remember our rules about 4. Like if 4 goes into it, 4 goes into the last two numbers. If 9 goes into it, I add them up and 9 goes into that number. Why am I focusing on 4 and 9? Why am I focusing on 4 and 9?
Because 4 times 9 is 36.
Well, because 4 and 9 are both perfect squares, yes?
Yep.
Okay, now if I don't know those, could I break it all the way down and do the pairs? Yes, but hopefully you start doing this more efficiently.
Could you like separate them? Like, because there's 36 and 9 in that. Could you do something with that?
Mm-mm.
No.
Okay, so we have 9 times. 9 goes into 36, how many times? 4. Chance just told you 9 times 6 was 9 times 4 was 36.
I did, yeah.
48 is 12. Oh, wait. 108 is 12 times 9. Where are you getting 12? No, you said 12.
No, you said
Nobody
12.
said 12.
No, I
Someone
said
said 12. Okay, 9 goes into 9 how many times? 1. Okay, 41. Can I break 41 down any further? No, I'm done with it. So, there's no perfect square in 41. What's the square root of 9? 3. So, AB is 3 square root of 41.
So you need a line above it.
What do you get the 1 out
Yes.
again?
Well, what's 9 times? What?
I'm dividing
Yeah.
369 by 9. So 9 goes into 36 4 times,
Oh, gotcha.
and 9 goes in. Okay. B. What am I looking for there?
Side.
No.
No,
You're looking
a
for
leg.
A and B,
You're looking
so
for a
it's
leg.
gonna be
A leg. Okay, we're not gonna have sides anymore because they're right triangles, right? We're gonna have legs and a hypotenuse.
Yeah. So.
Okay, so we want a leg.
A equals C minus
10
7.
squared minus 7 squared equals
Okay, so EF will make it A. Doesn't matter if I made it B. No. It's gonna be 10. How do I know 10 is C?
Longest.
But how?
It's the longest
It's the longest and it's across from the right angle, all that kind of stuff, right? So 10 squared is
100.
100 minus 49.
Which is 51.
So EF is the square root of 51, and I can't break down 51 any further, can I? Actually, I could. 5 plus 1 is
Oh, that's good.
3. Right, 5 plus 1 is 6, yes?
Yeah,
So 3 goes into it, doesn't it?
yeah,
Okay, so let's check. So 3 goes into 5 how many times?
once,
Once,
and then
With-
21.
2 left over, so I get
21, so
17. So I get 3 times 17, so I'm good there, right? There's no perfect squares in it. So I need to check. I just said, oh, it couldn't because I knew it.
So is EF equal to 3 squares of
No, because
Y?
3, let me answer. You asked. 3 and 17, neither one of those are perfect squares, correct?
Yes.
So it's 3 times 17 is 51. So here is my answer. This is us checking whether we could break it down or not. Okay. Well, the only you may struggle with it, but you're gonna have to keep doing it. So hopefully you'll get better at it. Okay. And if we're not struggling, we're not learning, and we always want to learn, right? Okay. So is this triangle a right triangle? I could also ask you, is this a Pythagorean triple? Either way, we have to check if what works. Pythagorean theorem works. If the Pythagorean theorem works, it's a right triangle, correct?
Yeah.
So I need to know the hypotenuse. The hypotenuse is across from the right angle, but I don't have an angle
But you can use the longest one, which
because
is
it has to be the longest one if it's a right triangle, correct? So if this is a right triangle, 37 squared is going to equal what?
35 plus 12 squared.
You forgot to square your 35.
I meant, when I said squared, I meant.
No. Okay. What you said was that.
I know what I said, but I meant it in a different way.
Okay. Connor said this. Is that right?
No, not at
Yes.
all. That's not even close.
Okay.
No.
So on what Connor said, what would I do first? I would add and then square.
Yeah.
Now, what do I have to do first, though? You have to
Square
square,
them.
then add. Is that going to be a completely different?
Yes.
Yes.
No, when I said squared, I meant like I said 35 first, but I meant to put the square, and that's when I said 12 squared. I was hoping you put the square after both of them.
Okay. So 37 squared, you'd figure out, is 1369. Okay. That is not one of our perfect squares that you should know, right? So that would be one you'd have to work out, and you get 1369. And then 35 squared, you would work it out and get 1225. And 12 squared, you should know, is 144. So the left is done. We're good. So the right better equal 1369 if this is a right triangle.
It says,
And it does.
yeah.
Okay. So this is a right triangle.
See.
So it's OMN. It's a right triangle. And what is the 90-degree angle? M, because it's across from the longest side, correct? Angle M equals 90 degrees. So this is just reviewing kind of what we've already done, yes? Now we're going to get into the new stuff. The new stuff is going to help us out because every right triangle we can solve with the Pythagorean theorem. But these two special right triangles, we can solve with just the ratios. We've been talking about similar triangles, correct?
Sure.
And similar triangles, the angles are congruent, but the side lengths are proportional, meaning they have a ratio, a scale factor, don't they? So I'm going to give those to you so we can use them once we figure out the first part. I am going to show you two different ratios for one of them, and I will explain why. We're first going to start with 30, 60, 90, just because I want to show you something, and next year I'm going to switch these two around. Okay, 30, 60, 90. When I have this, this is always going to be a right triangle because 30 and 60 add up to 90, well, as long as there's a right angle, correct? Now, when we do placement, we always go across from an angle, just like with the hypotenuse. Which side is going to be my shortest side? The side across from what angle?
90-degree angle, 30 degree.
shortest side from 30 degrees. 90 degrees is going to be the longest. So across from my 30 is going to be my shortest side every single time. So it is going to be A. Just a variable we chose. Could I use X if I wanted to? Yes. It doesn't matter. Across from 60, oh, what's in front of that A that we don't show, that we don't write? What number is in front of every variable? 1. If it was a 2, I'd put a 2, wouldn't I? Yeah. If I put an X there, you know that's 1X, right? This is 1A, isn't it? Okay. So across from 60 is A square root of 2. So I gotta know A, I gotta know 30 to get 60, don't I? I have to know the A. Have to know the A. And then across from 90 is 2A. Okay, that's what it is. I like to write mine like 30, 60, 90, and write it right across. What was across from 30? A. What was across from 60? This is not right. A square root of 3. A square root of 3, guys, sorry. It should be
It
like,
still doesn't make any sense.
well, you haven't used it. We could prove it, and then your brain would explode because I proved it. Does that make sense, Connor?
Uh-huh.
So just trust me. Okay. And across from 90 is what? 2A, and that should not be an equal. Now, you guys found, when you were working in the last section with similar triangles, you found 30, 60, 90 triangles. You found them over and over and over again. You found triangles with the side length of 2, 2 square root of 3, and 4. You found side lengths with 5, 5 square root of 3, and 10. What am I changing? 5, 5 square root of 3, 10. 2, 2 square root of 3, 4. 8, 8 square root of 3, 16. What am I changing in here? And the A. I'm making it, I'm lengthening those sides. You found those. You just didn't know you were finding them. I got you. Hello? No. Didn't know marker accent. I did not. I'm sorry. Yes. Okay, thank you. Bye.
Who's that say?
Right. Okay. So, what? It was a sheep. Is the sheep one? Okay, so that is what is changing. I'm taking those angles and I'm making this triangle huge and little, back and forth. So, this is a 30, 60, 90 triangle. Yes? What part do I have?
The hypotenuse.
The hypotenuse. What is the ratio for the hypotenuse? 2A. So if I figure out what A is, can I find the other sides of this triangle?
Yeah, you
Yes? So 10,
it'd be 5.
10 equals 2A. We're going to set the equation up because it's not always going to be that easy.
Could you just do 2A equals 10?
Well, it doesn't matter. 2A equals 10, 10 equals 2A, is it the same thing? Yeah. Yep. I divide by 2. The 2's reduced and A equals what? 5. So since A equals 5, we come up to the rest of my triangle, yes? So this side right here is across from 30, right?
It's just
So it's just A, and what was A?
5.
5. This side is across from 60, so it's A square root of 3. So it's 5 square root of 3. So whatever side whatever part of the right triangle they give me, I set it equal to its ratio to find out what is. What's in every single one of these? A. Once I find out what A is, I'm good to go, right? So you're hoping every single time they give you the 30 to cut the leg across from 30 degrees, right? Why would you hope that? Because that's just A, right? Guess what they're not going to do every single time? Give you A. Okay, now what do I have?
30, 60, 90.
I have 30, 60, 90 also. So as soon as I see 30, 60, 90, I should be thinking A squared of 3, 2A.
But you don't have the hypotenuse.
I don't have the hypotenuse, I have what?
A leg.
A leg. Which leg?
The
This is-
biggest.
No, this is the A.
This the biggest leg,
A
which is
squared
60. What's the ratio for across from 60?
A
A squared of 3.
A squared 3. So I take 28 equals what?
square root of 3.
So I need to solve for A, don't I? This is going to be some work. And once your brain wraps around it, it's going to be pretty easy because the same thing happens every time. Just the numbers are a little different. But you do the same process every time. Okay, so I'm going to divide by the square root of 3. Everybody good with that?
Yeah.
Okay, this is where I lose you. Hopefully not. Okay, those reduce to 1. So I have A equals 28 square root of 3. I cannot leave a square root in the denominator. Can't do it.
So what do you put?
So now I need to move it. I need to get rid of a square root. Well, if I have something squared, I take the square root, correct?
Yeah.
So how do I get rid of a square root? I
Square it.
square it. But in this case, I can't square, like, I have to, what do I multiply it by if I square it? It would be the square root of what? 3, yes? But whatever I do to the bottom, I have to do to the top. I should use my proper words. Whatever I do to the denominator, I have to do to the numerator. So it's square root of 3 and then the square root of 3, yes? And this is multiplied. So I'm going to have A equals 28 square root of 3. That's my numerator. Now my denominator, I have the square root of 3
So just be
times the
A.
square root of 3, which is the square root of what? 9,
So just be 3.
which is 3. That is going to happen every single time. Square root of 7 times the square root of 7 is what? 49. So it would be the square root of 49, which is 7. So anytime you multiply a square root by itself, you're going to get what's inside every single time.
So when we're doing this, do we even have to like do all those steps?
Once you get that process and what's going to happen, like I see it, and I can just tell you. Like I would see 28 equals A squared of 3, and I would tell you 28 squared of 3 over 3. Because I've done it so much. But today I want you to do the process so it gets in there. But
Right.
once you get there, the setup and the final, and I'm good.
Okay.
I want to always see your setup.
Yeah.
Okay, so now that I know A, can I plug it in and find everything else? Yeah? Okay, so AB is across from C, the hypotenuse, yes? What's the ratio for my hypotenuse?
2A.
2A.
So it's double that.
So it's 2A, well it's 2 times 28 square root of 3 over 3. Well, unfortunately 3 and 2 don't reduce, right? So 28 times 2 is 56 square root of 3 over 3 is your AB. All I did was plugged in my A. Now, are we going to have nice numbers?
No.
Not very often. Not very often. If you get a 3, 4, 5 triangle, that is a very good triangle to know. It's a Pythagorean triple. 3, 4, 5. Every time. And if you can reduce it down, the side lengths, to 3, 4, 5, like divide every side length by one number and get 3, 4, 5, you know it's the right triangle. So if you have 5 as a hypotenuse, 3 as a leg, you know it's 4 as the other. Okay. But you have to do it over and over and over and over again before you convince your brain that it's true. Okay, so now I have that. Well, across from 30 is going to be really easy, isn't it? It's just A, which is what? 28 square root of 3 over 3. So is it going to be a pain a little bit?
Yeah.
Yeah. But not horrible as long as you just do the math, right? So now we're going to go to a 45, 45, 90 triangle. 45, 45, 90. It's been a long time since I taught geometry, till this year, okay? But I've taught trig for a long time. And in trig, you have to use 30, 60, 90, and 45, 45 like every single day for an entire semester. So you should know them, right? Well, when I first started teaching it, I'm going to give you the first ratio that I'm going to give you, and that's what everybody gives. And I'm like, oh, yeah, let's go. Well, then people had to remember 6 different things, and they were always mixing them up. But I'm like, wait a second, why can't I make this one part the same? So I'm going to show you a little trick. I'm going to show you what the book shows you, and I'm going to show you what everybody else in the world thinks is great and wonderful. Okay, so 45, 45, 90 triangle, that is a nice isosceles triangle, yes?
Yes.
We know that the sides opposite the congruent angles are congruent as well. Do we not? We know that? Yes? So they tell you A and A. That's what they tell you. Okay? Well, if I were to do this, if I had A and A, so if I wanted C, correct? Over here would be the square root of A squared plus A squared. Well, wouldn't that be 2A squared?
Yeah.
And the square root of 2A squared would be A square root of 2. Wouldn't it? Okay. So just did Pythagorean theorem and got that. Every single 45, 45, 90 triangle, that is going to work. Okay. So I can write A. I love how it doesn't work up there. I don't understand why. Okay, so A squared of 2. Yes?
Yes.
But what do you notice about that and like my 30, 60, 90? Well, I can't get them both on there. 30, 60, 90,
They were all different.
the 30, 60, 90, this is what I write on my paper right away. Did I do them all? Real quick? Do I have them? Right there. Good, right? Because it's a cross, it just drops down. But wouldn't it be nice if 90 was the same? Wouldn't it? Because 90 and 30, 60, 90 is 2A, and 90 and a 45, 45, 90 is A square root of 2. Wouldn't it be nice if they were the same?
Yeah.
Okay, well, let's see if we can do some math and make them the same. Because we should be able to, correct? So we're going to look right here. If I want that to be 2A, well, how do I make the square root of 2 just to be 2?
Times it by the square root.
Times it by the square root of 2, yes? And we know as long as I multiply every single thing there by the square root of 2, I can do it, right? It's legal. So multiply by square root of 2. Every part. So if I multiply every part in here by square root of 2, what do my legs turn into? A square root of 2. Yes? But my hypotenuse,
I get 8.
it's going to be 2 times, no, square root of 2 times the square root of 2, divided by 8, yes? The square root of 2 times the square root of 2 is just what? 2. So I get now what?
It just goes out.
I get 2A. Now if I would use this, if I use this one, do I have the same hypotenuse ratio? And that makes it, instead of having to remember 6 things, I only have to remember what?
3.
5? Because I have 2 triangles?
Yeah.
Okay. I only have to remember 5. Would that be easier? Yeah. And it really doesn't matter, guys. You're still going to have to multiply. And what we did with that square root of 3 at the bottom, it's called rationalizing. You're still going to have to do that with either one. Now, when you get really good, you remember both of them. Because if they give you a leg, you want to use the top one. Because it's just A. If they give you the hypotenuse, you want to use the bottom one because it's 2A. See that? When you get really good. But we're not there yet, are we? So what I want us to do is try to use that bottom one. And why do I want to use the bottom one? Why do I want to use the second one? rather than the
Easy.
first. So my 90 degrees is the same. Now, if you go watch some video on Khan Academy or you watch the videos from the book, I can guarantee you're going to do the first one, but you get the same answer either way. I promise you. Got it? Okay. So, oh wait, I think I can keep. Okay. So we had, what did they give me?
X, Y, and Z.
They gave me a leg, didn't they?
Yeah.
Okay. So I know, since this is an isosceles triangle, the cross from the 45s have to be the same, yes? So XZ has to be what? 7. Has to be. Doesn't matter, has to be 7. I can figure it out, and I'll check my work here in a second. But now I have to get this one, which we're going to use the 2A, aren't we? We're going to use 2A, so we have to figure out what A is, don't we? So we have 7 equals what?
2A.
No, what's 7 is a leg,
Okay.
so it's A square root of 2. Okay, 7 is across from 45. Everyone see that? So we go 45 and drop down and use what? A square root of 2. So now I have to solve for A, yes? So what do?
You just times by 2.
I divide by the square root of 2. And now I have to multiply by what? Square root of 2. So I get 7 square root of 2 over square root of 2 times the square root of 2 is 2. So A is 7 square root of 2 over 2.
Okay, now.
Let me finish. And I know what you're thinking. Let me finish. Okay? So now what do I do with this?
You just put, like, don't you?
I plug it right in here, don't I?
Yep.
So it's going to be 2 times 7 square root of 2 over 2. My 2's reduced, correct?
Yep.
And I get 7 square root of 2. Now Connor was going to say, well, if we just use the first one, or you?
No, I was
Oh.
gonna say since they're both 7, wouldn't we only have to do it once since both legs are 7?
Okay, I thought you were going to bring up the point. Okay, now look at the top one. Look at the first ratio. A was what? 7. Okay, but that only works nice when you have that, yes? And you've got to remember those ratios, don't you? And right now, you don't know them yet, do you? So I don't care. If you want to learn 3 of them, go for it. Anybody want to learn 3 ratios? No? You want to learn 2 ratios that are completely separate? I don't care which one you use, but you see the value of using the boxed one. Okay? So now, let's do the next one. I'm going to use my box. We're going to use the box one again. This next triangle, what part did they give you? 14. Across from the 90 is the hypotenuse, yes? So across from 90, what's my ratio?
2A.
2A. So 2A equals what? 14? So A equals 7. Well, A equals 7, so the 2, now in this one, the legs are A squared of 2, yes? And what's A? 7. So it would be 7 squared of 2, wouldn't it? And this side would also be what?
Same thing.
7 squared of 2. Now, if I use the first ratio, A squared of 2. If I use that one, I would have what? 14 equals A squared of 2. If you don't want to write this down, you don't have to. And then I would have to multiply or divide by what?
2.
Square root of 2.
You get 14.
And then square root of 2. Square root of 2. So A would be 14 square root of 2 over 2. which would be what? 7 square root of 2. Did I get the same answer?
Yeah.
Yes. So either one I use, am I going to have to do the same math at one point? Unless I remember both of them and then can switch back and forth. When you get really good, you can use both of them and switch back and forth. But I want you to be comfortable with at least one. Okay, guys? At least one. Questions? So, you need to, actually, since we got done in time, I am happy to start your assignment with you if you would like to do that. Would you like to do that?
Yeah.
Brian, you aren't looking at your phone, are you? You're not like really trying to look at that. Every time I turn around, I catch you looking down and mess it in your pocket.
Wait, is it a book?
Yes, it is book assignment, guys. 351, 4 through 8, 15, 16, 20 through 22. So grab a book real quick. Oh, I didn't